This is just stuff that we went over last time. Now we got 7/11 minus 4/11 right there. And these are both in 11ths already. So I'm going to show mathematically the steps here in 11ths, right? Now remember, we don't do anything with the denominator because that tells us the sizes of the pieces that we're dealing with. All we work with is the numerators. And yeah, it's subtraction. It says in the beginning you had 7 of the 11ths, and then you're going to take away 4 of those 7 11ths. So in the end, you're still going to end up with 11th size pieces, but then 7 minus 4 is 3. Boom. Stuff, right? This one came as 7 11ths and 4 11ths. The difference today is that we're going to have to force the mixed numbers to become improper fractions. I know these two are proper fractions, but we should be able to make our mixed numbers improper fractions. And subtracting mixed numbers. But again, the extra step is to force the mixed number to become an improper fraction. And then in the end, if it's addition, of course, we'll end up having to change it back to a mixed number. But if it's subtraction, sometimes our answers will end up being or proper fractions, so there's no need to change it back, which would be great news. Cycle method, by the way, is not a formal name. Like you probably wouldn't be able to find that in a math text somewhere. I suppose you could. I'm just not familiar with it being formal. So, yeah, any mixed numbers that we see, we're going to use this cycle method to change it into a improper fraction. Now, in doing so, just remember that your denominator, which comes from the fractional part of the mixed number, will remain what it is. So in this case, it's using the letter C abstractly, but of course that would be a number, like maybe 5. If it was 5, you would keep it as 5. And then you would end up with a new numerator with what we have here as cycle method. So it's A times C, whatever that product is, then we add the B value, the numerator. Okay, so yeah, changing improper fractions to mixed numbers. We use long division for that. This is what we will usually end up having to do at the end of the problem after we've done the operation of either addition or subtraction. So if we have mixed numbers to start with, then in the end we should have mixed numbers as our answers. I believe you'll need that on the assignment because if you don't use the mixed numbers, it's gonna say, well, no, I won't accept it. So if you're putting in improper fractions into this assignment, then it won't accept it. You'll get marked points. Okay, so the long division, which we know, we would use a long division symbol here. The two parts, you have the numerator, which in the past we would say is the dividend. So the numerator goes inside the long division. Okay, and then the denominator is what we divide by. Of course, that would be our new denominator as well. But that ends up being what we used to call the divisor. So dividend. No. Crap. Correct letters, just I was going for the wrong word. Divide. Oh, crap. All right, I got the two parts of the fraction there. So the numerator, the top number, goes inside the long division, and then the denominator is the divisor. Oh, that's what a denominator. That's what I was going for. I'm gonna get it. Denominator. Okay, now from this, you should end up with some kind of quotient, which we usually have above. Quotient. And then in the end, down here, you're gonna have some kind of remainder. And the quotient is the whole number in the mixed number, and then your remainder is your new numerator. Now again, this is what you would do with your improper fraction at the very end. Are the numbers that we're going to be using, especially the denominator here, are they going to be nice numbers? Not always. You know, they may use something like 17 or 13. I don't expect them to use anything like 258, though, because, well, I guess I wouldn't put it past them, but it's just unlikely that they will right now. This one's not new for us. But yeah, when we get, just like we saw on the starter problem, if the denominators match, we keep the denominator the same for both addition and subtraction because that tells us the sizes of the piece. And then we just operate with the numerators, whether it's addition or subtraction. Now subtraction, of course, if we have mixed numbers in the beginning and we've changed them into improper fractions, addition will only make those numbers bigger. So the answers to those should end up being mixed numbers that we would have changed from this improper fraction. But subtraction, sometimes we'll subtract enough that we end up with a proper fraction, which will be good. So yeah, in the end, it's always good to check our answers after the operation, because if they can be simplified, then they should. And we look for, we're going to use divisibility rules, specifically divisibility by 2, 3, 5. I mean, those are our main ones, but we can always kind of check for some other different ones like 7 or 7 to 11, maybe 13, something like that. So it looks like 3 simple steps. When I say operate right here, I mean, sometimes that can get a little complicated, even the changing the numbers in format. But the first step, if we have mixed numbers, change those to improper fractions. Number 2, operate, meaning addition or subtraction. And then in the end, we'll have our improper fraction mostly, which we would then change to a mixed number. 3 steps. So right here, my first fraction, I got 7 and 3/7. This fraction, when I change it into an improper fraction, will still be in 7ths. So I'm going to set that up right now in 7ths. But I've got to use cycle method in order to get my new numerator, right? Now this new fraction that I'm creating here is going to be exactly the same value as the mixed number that I'm starting with here, the 7 and 3/7. So, cycle method. That'll be multiplication. That's 7 times 7, which is 49. And then I will add the numerator, 3, 49 plus 3. 9 plus 3 would be 12, carry the 1. 1 plus 4 is 5. So that is 52/7. Again, this is exactly the same value as the 7 and 3/7. It's just changing the format so that it will hopefully be easier to work with when we do the subtraction. Okay, so that's the first mixed number. The second mixed number, 2 and 4/7. Once again, the denominator 7ths is going to stay the same. And this is nice for us because this means we do not need to force the denominators to match when we get to the point that we want to subtract, and we will eventually. But as of now, let's take the 2 and 4/7 and get our equivalent numerator, but changing the format, right? So that would be first 2 times 7, which is 14. Now add the numerator 4, and 4 plus 4 is 8. Drop the 1, 18. So at this point, if the denominators did not match, I would have to force them to match, but they do, because it's very generous. Which means that I can go straight into operating with the subtraction in 7ths, right? The denominator 7ths here is not going to change because we're dealing with the same size pieces. Well, how many pieces are we dealing with? You got 52 to start with, and then you're going to take away 18 pieces. Oh, it said add, and whatever. Okay, so this one, 7ths. Just keep in mind if we did do addition, it would just have an addition sign between this, and then you'd probably be adding instead, whatever. But now, 52 minus 18, let's do that. I'll do the work up here in the top right. 52 minus the 18. Okay, so I'll make that 12, borrow from the 5/10s. 12 minus 8 would be 4. 4 minus 1 is 3. So we end up with 34/7. Now, 34/7 is pretty good, and it should be our answer, but it's in the wrong format because we started with mixed numbers, right? So that means we've got to go back we got to change this 34/7 back into a mixed number. And we're going to do that with long division. So our numerator, 34, we're going to divide that by 7, our denominator. And even in changing this back into a mixed number, we should end up with a common denominator of 7 because the sizes of the pieces have not changed. So 7 will not go into 3, so I can put a 0 there to hold that place value, but it will go into 34 4 times. 4 times 7 is 28. So when I subtract, I should get a remainder. I would make that 14 minus 8, which is 6. So my quotient, 4, is my whole value of the mixed number, and the remainder is 6. is my numerator. Last thing I should do, look, just like we should always do, is check this fraction to see if it can be simplified. Could we have checked right here? We could have. And I know 34 is divisible by 2, 2 and 17. 7 is not divisible by either of those. Or you could just say 34 is not divisible by 7. That's fine. But yeah, the 6/7 also, that cannot be simplified, which means we have in fact found our final answer. Boom. So we're going to go through this 6 2/3 plus 3 3/5. Of course, the denominators don't match. Now, is it possible you could make the denominators match right now? Yes, you could. Would that make it easier? I don't know. But I'm not going to do it. So you're welcome to try it out if you'd like. You should get the same answer. If you do, I'm just not going to do it. By the way, there's another method, which I'm not going to show, where you can just kind of add these directly, but that usually comes with a little bit more experience. So I'm not going to show that either. What I will do is go through the process we've discussed, meaning I'm going to take that 6 2/3 to start with, and I'm going to change it to an improper fraction. Of course, the denominator will still be in thirds, but I will get a new numerator by taking the whole value, 6, multiplying it by the denominator. So that'd be 6 times 3, which is 18. That's times right there. And then cycle method, we would add the numerator. So 18 plus 2, boom, 20. So my new numerator is 20. Now, I just can't stress this enough. 20/3 has the exact same value as the 6 2/3. Now we're going to go to the 3 3/5. Well, that's dealing in fifths, so we'll keep the denominator in fifths. Now we use cycle method there, so 3 times 5 to start with, which is 15. And then 5, we'll take that and then add the 3 numerator. So 5 plus 3 is 8, drop the 1. We end up with 18/5. So once again, and I'm using the right operation this time, but 18/5 has the same exact, it is the exact same value as 3 3/5. So these two, let's go over a common error. So I'm showing you what not to do right now because it's common enough. But what we end up seeing sometimes on a test is students will be like, oh, boom, 3 plus 5 is 8, and then 20 plus 18 is 38, and then they'll simplify this. And the simplification sometimes is good. But you shouldn't do this. You should never do this because you can't add denominators, usually. So we are not going to do that method. Please never do that thing that I just showed you. But what we do need is the same size pieces, right? That's what the denominators usually tell us. So we need to change these into new fractions, but with new denominators that match. Now you're welcome to make a list of multiples or use prime factorization to find the lowest common denominator. As you know, I don't care about that. So I'm just going to force the denominators to match by I'll take the second denominator this time, 5, and multiply it into the first fraction. Now what this does in the denominator, we'd get 5 times 3, which is 15. So I'm expecting 15ths. And in the numerator, we've got 5 times 20, which you can stack and multiply, or you can just do 2 times 5, which is 10, and then tack the 0 on, which would then be 115ths. Excuse me. Now we'll take the first denominator, 3, and multiply that into the denominator and numerator of the second fraction. So 5 times 3, again, is 15. That was part of the deal to make that denominator be the same. But then I'd have to do 18 times 3. So 18 times 3, 3 times 8 is 24, carry the 2. 3 times 1 is 3, but added the 2 makes that 5. So 54/15. Now some students look, and we kind of view these two fractions as being different as well. They're the same exact value as these improper fractions that we started with, which were the same value as these mixed numbers that we started with. But again, we're changing these with purpose. First, we changed these mixed numbers into improper fractions so that we could work directly with the fractions. Now we change these fractions into these new improper fractions because we needed the denominators to match. Now that the denominators do match, well, we can take those size pieces, which are 15ths, and just combine, or add in this case, the two numerators of 100 and 54. Okay, with this then, let's go ahead and add 100 and 54. So we're still in 15ths though. So this will give us a new numerator. All right, 100 plus 54 there. It's pretty easy. 0 plus 4 is 4. 0 plus 5 is 5. Drop the 1. Now 154/15ths. Now that answer should be good enough as a improper fraction. But since we started with mixed numbers here in the beginning, we should change this back into a mixed number in the end. Like I said, otherwise the assignment is not likely to accept the answer. So our mixed number will still have 15ths as our denominator, but we need a whole value and also a numerator. So we're going to have to use some long division. Long division, we take the numerator, 154, and we will divide this by the denominator, 15. The quotient will be our whole value, and then the remainder will be our numerator. So 15 will not go into the 100s, but it will go into the 15 tens once. 1 times 5 is 15. We used up all that garbage. So there's a 0. We'll drop the 4. Okay, well, as far as I know, 15 does not go into 4. Oh, by the way, notice I did not list the multiples of 15 just because this one worked out pretty nice. But if you wanted to list them, you could. Now, of course, 0 times 15 is 0, which means that actually the 4 is our remainder. So I should probably make that a different color, huh? Remainder 4. So our quotient being 10 would be the whole value of the mixed number, and the remainder 4 is our numerator. There we go. All right, so first up, 7 and 6/13. Of course, we're going to make this 13ths because our original mixed number has 13ths. So now we'll do cycle method, okay, on our first fraction. So we'll do first 7 times 13, which I got to stack and multiply this now. 7 times 3 would be 21. Okay, so that 91 then. Unbelievable. Yeah, I still got to add the 6 numerator. I don't know if I was making that mistake because I stacked and added or what, but 97 is the true numerator that we need right there. So, okay, so the next fraction is going to be in 13ths. This is gonna really dent my confidence today. Here we go. Well, no, it's okay. Well, I can recover. But yeah, we gotta start out with 5 times 13, which I guess we kind of already did. So I'm going to speed through that part though. 3 times 5 is 15. Carry the 1. 5 times 1 is 5, but add the 1 is 6. 65. Don't stop there. Like I did before. Make sure you add the numerator 11 in there. So that's going to be 76 now. So still 76. I guess we kind of did that second time correct, but missed that other one. So here, again, most students will skip this step when they're showing the work, which would be okay. But we still need to show that we're gonna take the 97 and add the 76. So let's go and do that. 97. I'll show the work. 97 plus 76, which is going to give me a new denominator. Dang it. See, that's where I'm going now. So it's going to give me a new numerator. We're going to keep the denominator the same. Let's go and add these together. 7 plus 6 would be 13. 1 plus 9 is 10. Plus 7 would be 17. Okay. So 173. This is seeming already much better. I hope it is. But now that we have that, we've got to change this improper fraction, which looks like it cannot be simplified, into a mixed number. So our mixed number will keep 13ths as the denominator, but we've got to do some long division here. 173 divided by 13. So multiples of 13. Okay, well, 13 will only go into 17 once. Well, I should start from the beginning, shouldn't I? 13 will not go into 1, but it will go into 17 once. There we go. 1 times 13 is 13. When I take that out, I got 4 left over. Drop the 3. So I went a little too far in my multiples. That's okay, because we do not need to memorize our 13 multiplication tables. 13 will go into 43. It appears 3 times. 3 times 13 is, that's our third multiple, 39 there. So when I subtract, I should get the remainder. I'll borrow from the 4. 13 minus 9 is 4. Okay, so our quotient, 13, and our remainder, 4. And that should do it. This one now starts with a whole value plus a mixed number. Now I'm going to take a shortcut on this one, even though in the end, just like we should always do, by looking at the 2/4, I would assume that the answer should be able to be simplified. Now, yeah, so we'll get to that part, but I'm going to give a shortcut on this one if, and this is only going to be good for addition. Okay, now you could use cycle method here and you could find common denominators, which really, I don't know, I don't think it would be too difficult. But really what we have is 74 plus 10, okay? So that's what I would say, just kind of start with. Take your whole values and add those two. So that would be 74 plus 10. So 4 plus 0 is 4, 7 plus 1 is 8, and that would be 84. Okay, then you just tack the fraction on, 2/4, boom. Now, like I was saying though, 84 and 2/4 is good, it's a good mixed number, but the fractional part of that can be simplified because 2 and 4 are both divisible by 2. So we should simplify them, okay? So the whole value of our mixed number stays the same, but we'll have new numerators. 2 divided by 2 is 1, and denominators, 4 divided by 2 is 2. Now that fraction is fully simplified, and that's the value that we want. When it's addition, we can do this. If this was a subtraction right here, we would not be able to do this directly. It would take a lot more, well, not a lot more work, but it kind of takes us out of the algorithm of changing our mixed numbers into improper fractions, getting common denominators, adding or subtracting, and then making the final answer a mixed number. So, but this one's good. This one, right off the bat, we see the denominators do not match. So we're definitely going to have to make the denominators match, which is okay. But we're going to go through our process. We're going to force the denominators are going to force to match. But right now, we're going to change these mixed numbers into improper fractions. And yeah, it's not going to change the subtraction either. So 5ths and 6ths is okay. But here, we got cycle method, which I will make a note in my mind and not to forget the addition part of that. I'm going to try anyways. So 6 times 5 to start out with, which would be 30. And then we add the numerator of 4 to get 4 and 3, 34. 34 fifths. Now cycle method on the 2 and 1/6. So we already have our 6th, but we're going to start with 2 times 6, which is 12. Then add the 1 numerator to make 13. So 34 fifths minus 13 sixths. Pretty close, right? We got denominators that are closer, pretty close to the same size, but they're not quite the same. Which means that we're going to have to force those denominators to match. Okay? Now, it's still subtraction, and that's fine. So you can find a denominator that is the lowest common denominator with listing or prime factorization, but I'm going to go straight to our method of just multiplying the denominators into the other fraction. Meaning the 6 here in the second fraction denominator, I'm going to multiply into the 5, 6 times 5 denominator, but also the numerator of 34, okay? So in the denominator, 6 times 5 is 30. Now, just to get ahead of myself here, which I hope doesn't cause confusion, that means that I am also expecting this other denominator to also match as 30. Okay, but let's get that other denominator first, okay? So that would be 6 times 34. So 6 times 4 is 24, carry the 2. 6 times 3 is 18, but add the 2 makes 20. So we end up with 204 thirtieths. And now I take the 5 denominator and multiply it into the denominator and numerator of the second fraction. So 6 times 5 Yeah, as we had planned, that did force the denominators to match as 30. But now I've got to do 13 times 5, which we've already done. 5 times 3 is 15, carry the 1. 5 times 1 is 5, but add the 1 is 6. So we have now 65 thirtieths. Okay, so that was all in an effort to force the denominators to match, which means now I am ready to combine the numerators with subtraction. So the thirtieths will remain thirtieths. We're going to subtract 204 and 65. All right, when we go to subtract these, we will still have 30th size pieces, but I've got to do some subtraction. So 204 minus the 65. It's giving me my new numerator. So the 14, I'd have to borrow from the 20 to make it 19. 14 minus 5 would be 9. 19 minus 6 would be 13. Okay, so that ends up being 139 thirtieths. Probably a little bit more space there. And yeah, that's our improper fraction. What we would like is a mixed number, though, in thirtieths. So we're going to divide by 30, 139. Okay, multiples of 30, 30, 60, 90, 120. I guess we could go to 150. Now, I'm not showing the addition because I'm just taking 3 and finding multiples of it and then tacking a 0 on. So 30 will not go into 1. It will also not go into 13, but it will go into 139, only the 120. That's 1, 2, 3, fourth multiple. So 4 times 30 I see is 120. And when I subtract, I should get the remainder directly. Okay, so 9 minus 0 is 9. 3 minus 2 is 1. And then the 1's 0 out. So we get a quotient of 4 with the remainder of 19. Now, before I complete this problem, which it is complete, by the way, that should be our answer, and I don't see that I made any errors this time. Well, not yet anyways. What they're going to do on this assignment as well, they're going to say, estimate the answer. So what you can do, if you want to estimate, is you can actually find the answer. Now, this means that the answer should be estimated to have been 4, but 5 would also work. Well, I guess 5 would be the estimate for this one. Okay, well, here's why the estimate would be 5 from the beginning. Because if you were to start with that 6 4/5 minus the 2 1/6, okay, so this first fraction we look and see that 6 4/5, the 4 numerator is bigger than half of the 5, which means this would estimate to 7. And then the second fraction, 2 1/6, again, you look at the numerator, 1, which is less than half of 6, so it would stay, or round down is what they would say it does. It would round down to a 2. So that would have been 7 minus 2, which would have been, and this is just the estimate of 5. Now, is 4 19 30ths close to 5? We don't care. It's just, this is how you would do the estimation process. So on a problem like this, we still got the 4 5/8. And yeah, we want this to be an improper fraction. So cycle method on this one, okay? So we're going to start with the 4 times the 8, which is 32. And then we'll add the 5 numerator to get 37. So that ends up being 37/8. Now this is minus 1, but I'm going to show it, instead of just being as 1, I'm going to show it as 1 over 1 so that we can use our fraction rules on this for subtraction. So we do need the denominators to match at this point. And I know that 8 is just a multiple of 1, so that's going to be good news for me. So we got the 37/8. But I can take that second fraction, 1 over 1, and just multiply the denominator by 8 to get a new denominator of 8 as well. Put that in the wrong place. But if you do it to the denominator, you got to do it to the numerator as well. And still 1 times 8 is 8. And now we've got 37 eighths minus 8 eighths, which then we're going to take this 8 and subtract the numerators of 37 and 8. So what is 37 minus 8? So we need to borrow 1 from the 3 there, so 17 minus 8 is 9, drop the 2. So this ends up being 29 eighths. So last thing we want is the mixed number from this improper fraction. So we'll have to use some long division, 29 divided by 8. And I know that 8 will go into 29. It won't go into 2, but 29 3 times. 3 times 8 is 24. When I subtract, I get my remainder of 5. So a quotient of 3 and a remainder of 5, 3 and 5/8, boom. Okay, now with this, and it only works this way if it's set up like this, so I'm kind of reluctant to show this. But a problem like this, where you have a mixed number minus a whole value like this, you could have just done 4 minus 1 to get the 3, and then tack the fraction on right there, okay? I still don't mind showing the process, because if it didn't work like that, like if it was like 11 minus 4 and 5/8, that process doesn't work. So you'd have to go through all these steps. So there's our objective. I can add or subtract with mixed numbers. We did a few problems there. There we go.